Okay, guys, this is part 4, I think, of neuro stuff, and today we're going to get into the nerve physiology. So we got to talk again about the sodium-potassium pump, and we're going to throw in some other things in there too. So remember, we had way up here, we had our happy-go-lucky nerve cell. And the nerve cell has this little guy that comes down like this, and then it eventually has a terminal end branch. We have a couple terminal end branches. Remember, these guys up here are called dendrites. And then there's the cell body, and then we have the axon hillock, and then we have these little things called Schwann cells around the outside. And what those do is those are the insulators. Remember, we had the in between them, and we're called the nodes of Ranvier, R-A-N-V-I-E-R. I'll try and put it up here somewhere. And this myelin sheath called a Schwann cell, Schwann cells in the peripheral nervous system. Remember, in the central nervous system, they're called oligodendrocytes. So the process of this whole thing, getting information from somewhere else, some other nerve. So imagine like here is a dendrite of another nerve coming down, and this is the sorry, not the dendrite, the terminal end branch. This is a dendrite. The connector of the two is called the synapse. I'll put that right here, the synapse. And that receives information, okay? It connects and says, hey, do some stuff. And what it does is it sends an electrical impulse because of depolarization, we'll talk about that in a second, all the way down the axon, inside those myelin sheath, all the way down to the next terminal end branch, to the next synapse. So let's look at, if we take this axon and we kind of blow it up, and we look at how big it is, a big old tube like this, right? And it goes all the way, say from here, and it's going this way. Okay, and this is put down like this, make it look like a tube. On the outside of it is going to be sodium, Na+. And on the inside is going to be potassium. So think of it, a way to remember this is sodium is only on the outside, sodium is salt. Okay, like sodium chloride is actually table salt. And oddly enough, there is some chloride floating around out here too. We're going to put that, and we're going to put it way up here somewhere, Cl. And chloride is negative, and Cl down here. Now, there's a little bit of that floating around there. So sodium chloride is salt water, basically. Salt water is a great conductor of electricity. Electricity is the movement of electrons. That's what we're trying to do here. So the sodium is mostly on the outside. Okay, we're going to say, normally when this is polarized, we have 3 on the outside here and 2 of these guys on the inside. So it's relatively more negative on the inside than the outside, relatively. Because there's more sodiums on the outside, that's way more positives. Say 3 positives, say we have 1 chloride, okay, that -1, but we have 3 sodiums. Okay, those are 3 positives, 1 negative. Here's 2 positives and 1 negative. So it's relatively negative on the inside versus the outside. That's called polarized. It's just ready to go. Now, when depolarization occurs, which is when a nerve impulse comes through, it's called an all or none thing. So once it starts, it just goes. It's kind of like dominoes. Okay, if you hit one domino, they go all the way down. It's very, very similar because that's the way it kind of happens. And once you start it, you have to do something big, like cut the nerve or something like that to stop it. It's all or none. It's just going to keep going until it can't go anymore. Basically, that's the idea. Okay, well, remember, this is basic anatomy, so we're not going to get too far into all the mumbo jumbo and doodads and all that junk. The potassium pump is trying to keep more sodium out and trying to keep more potassium in. That's its normal thing. When the nerve conduction comes down, it switches. And that moves really fast, and that causes a change in the electrons, and that causes the electric current. So that's why electricity can affect nerves. Now, also chemistry can affect nerves. It's an electrical chemical process, electrochemical. And because chemistry is there's a lot of electricity in there, you'd be surprised. And in electricity, there's a lot of chemistry involved. I mean, we have minerals that we use a lot, like copper or gold or aluminum or something. Those are kind of conductors. Those can move and receive and take electrons. Okay, and that's the process we want to understand with this. Other thing, it's all or none law. This is kind of a quick and dirty one for this thing. I wanted to review the nerve cell, get the sodium potassium pump. Again, I'll write that up here. And for today's side quest, which we'll put here, no, we'll put it down here. But side quest right there. Today's side quest is going to be, what is peripheral neuropathy? What does that mean? Okay, so I want you to leave the comments, the answer for this down in the comments below, and give us a thumbs up, and or whatever you want to do. And don't forget to subscribe, and make sure you're on the playlist for this to receive the next video in order of all of these, because I'm doing them in order for all the chapters in the book. So we've already done skeletal, we've done urinary and all this kind of stuff. This is also just as a side note. I'm going to keep using these later on if I can, and we'll get to know and understand things like the whole system, all of anatomy and physiology. I'm going to do the whole thing, the whole book. Anyway, this is Dr. Sean over at, well, I'm at home right now with my dogs on the floor, and down the basement where it's cold, and in stay-at-home orders or quarantine, whatever it's called. I'm not quarantined because I don't have it. But anyway, you guys take care and do your things and do your homework. Don't forget the question at the bottom, and we'll talk to you soon. Bye.